Hello learners, in this tutorial we are going to discuss about the methods or functions used in Java. Although the chapter name is user defined method, but we will discuss methods or functions from general point of view with an emphasis on user defined functions. Now before going into the details, I would like to introduce you the BlueJ software, where I encourage you to write and test your programs. Those who are having the facility of computer. Now BlueJ is a freeware, means it is easily available in internet. The downloadable link I have shared below this slide. As you can see, different versions of BlueJ software are available. You can choose the correct one as per your operating system installed in your PC. Obviously, along with BlueJ, the appropriate version of JRE or Java runtime environment have to be downloaded and installed. Now, to know how the BlueJ can be used to write, compile and run program, a video link is given in the description section of this video. Those who are interested can go through the video to know how the BlueJ software can be used. Okay, now back to our topic, functions or methods. From a general point of view, methods can be used to make a program modular or to partition a whole program or a big program into smaller part or module. Each module may take actually some inputs, perform its intended work and return the result. A pictorial representation of methods or functions is shown in this slide. As you can see, a whole program can be divided into different methods which has some specific purpose. Each method may take some input and return result. The definition is given here. I want you to memorize these definitions, as whenever questions arises, you have to write the definition which is given in the book. Okay, now the obvious questions arise: why methods are used? As we have seen in the previous slide, that methods divide the whole program into smaller section or module. Now, as methods divide the whole program into smaller modules, error detection becomes easy, as you can understand, because whenever a program divides into modules and if a module is not performing according to the need, so we can look into that module only to find what is the problem. So we don't have to look the whole program or to search the whole program for the error. Now the third point, that is methods or function eliminates code redundancy. How it is achieved is that methods are generally written perform a specific task. For example, a method can be written to perform sorting or to arrange a list of numbers into ascending or descending order. Now, once we have written a method to perform the sorting, we can use the same method in each part of the program where the sorting is needed. Hence, writing same section of code or same lines of code again or again can be eliminated. Hence, the code redundancy can be eliminated using method. Now, about the fourth point, that is method or functions allow easy update of the program, can be understood very easily. Say a program have 4 methods and we want to update a particular method so that the whole program performs a specific task in a better way. Now to update that method, we have to bother about only that portion of the whole program, that is that method only. We don't have to look up the whole program. Hence, the updation becomes easy if we use the method in program. Now, using functions or methods into our program comprises 2 aspects, that is function call and function definition. How these two works, that means how function call and function definition works, let's understand that with the help of this video clipping. Let's see it. Okay. Now once again, see the same clipping, one action at a time. See here, function call is there and function definition is also here. Now, function call provides a thrust or a push to the function definition to perform its intended work. Now, after function definition receives the thrust, it starts performing its intended work. Now, when the work is over, it produces the output, and the output return back to the function call. So, all in all, the function call works as cause and the function definition works as effect. Now, in the next slides, we will come one at a time these two aspects, that is function call and function definition. First, we will look in details about the function definition. Here, the general syntax of function definition is shown. As you can see, a function definition consists of access specifier, static keyword, return type, function name, and parameter list, along with a block of statement. Recall from your first and second chapter that a block of statement is a group of statement enclosed within a curly bracket. So a function definition consists of this line, which also consists of access specifier, static, return keyword, function name, parameter list, and this part where a group of statement is written inside an opening curly bracket and a closing curly bracket. An example of function definition is also shown here. As you can see here, the access specifier is public, then the static keyword, then the return type, here it is int, then the name of the function, that is add, and then two parameters x and y, and the data type of x and y are int and int respectively. Then comes the opening bracket and closing curly bracket. In between that, 3 lines of code are written here. Now I would like to mention here that this top part of the function definition, or this first line of function definition, is known as function header or function signature, and rest part, that is this block of statement, is known as function body. The intended work for this add function is very simple. It will receive two values, calculate their sum, and then return these values. I would like to emphasize the fact that the return type of this add function is int, and the last line of the function body of the add function is also a return statement. After that, a this jet variable whose data type is int, and this is no coincidence. Whenever a function has a return type anything other than void, then there must be a return statement at the last line of that body of that function, and the return value must be of the same data type as of the return type of this function, or these two types, that means the type of this value and the return type must be compatible one. What does it mean by compatible one? We'll discuss it in the later section, but you can see from this example that the return type of add function is int and the data type of z is also int, so it matches. That means whatever return type is there in the function definition, the return value must be of the same data type. Okay, so this is how a function definition must be written. Now let's put all together with the help of a simple example. Here I have written a class whose name is test, which has a function or method add, which receives two values. It calculates the addition of these two values, return, store the result of the addition into its field or instance variable, and then return the value. Now this is the function call. As you can see, to call a function we have used the object t1 of the class test, and using the dot operator, which is known as membership operator, we have called that add function. Now after the function call occurs, the program execution sequence jump from this function call to the function definition, and these values of a and b will be copied into x and y. So in this case, after this function call occurs, the value of x and y becomes 5 and 6. Now rest of the part is very simple. Then the result of addition of 5 and 6 occurs, that is 11. It gets stored into the variable result, and that 11 value returned, and that value gets stored into k, and the value of k is displayed. What we must remember here is that the values or the variables which are used in the function call are known as actual parameter, and the variables which are used in the function definition are known as formal parameter. So actual parameters are used in function call and formal parameters are used in function definition. Often these questions comes into your ICSE examination, the difference between actual parameter and formal parameter. So whatever we have learned, I have tabulated here. Actual parameters are used in function call. We have seen just in the previous slide, and the formal parameters are used in the function definition. You can see in the function call where the actual parameters are used, these actual parameters are not preceded with any data type. You can see from here, but the formal parameters are preceded with data type. So that makes our second point, actual parameter not preceded with data type, but formal parameter preceded with data type. Now about the third point, the actual parameters can be variables, or we can write the values of these variables directly here. That means in place of a and b we can write 5 and 6, but the formal parameters must always be variables. So that is our third point. Actual parameters can be variable or constant, but formal parameter must be always variables. Now here I have shown the difference between parameter and argument. Although in most of the literature and the programmers use these two terms synonymously, but often question comes in ICSE question papers, the difference between parameters and argument. For the sake of question answer, I have given this definition. What I meant here is that parameters are those which are used in the function definition, and the argument are those which are used in the function call. Now this concept will help you to understand that table of difference between parameter and argument. You can see generally parameters are those which are generally the variables that receives the passed values to a method as input, and argument are those what a method receives from the calling entity. Parameters are generally used in the function definition, and arguments are used in function call. So this is all about a difference between parameters and argument. Now that we have a little bit of understanding and or background about the methods or functions available in Java, we will see different type of functions available in Java. Functions or methods can be broadly classified into two categories in Java. These are user-defined methods and predefined or system-defined methods. User-defined methods are those which are defined by the users or the programmers, as we have done in the previous slides by defining the add function. predefined or system defined functions are already defined inside Java. We have used those predefined functions. Some example of predefined functions are println, pow, sqrt, etc. Now user defined functions again divide into two categories: pure function or accessor method and impure functions or mutator method. We'll see with the help of example what are pure function or accessor method and what are impure function or mutator method in next few slides. In this slide we have defined a class named customer having instance variable customer ID, purchase amount, and few methods such as customer entry, customer purchase, display details, etc. In the main method we have created object of the customer class, and using the object we have called several methods. Now in this slide I want to emphasize on the display details method. As you can see here that this method, inside this method, display details method, only the value of customer ID and purchase amount is being displayed, and no other values of the instance variables get changed here inside this display details method. So as the display details method does not change the value of any instance variable, therefore it's a pure method. By definition, pure methods are those functions or methods which does not change the state of an object. Recall from my previous videos that state of an object is defined by the values stored inside the instance variables inside an object. So as display details method does not change any value of the instance variables, therefore it is not changing the state of any object, hence it's a pure function. Now if we look the customer entry method of the customer class and the continue purchase method of this class, you can see that whenever the customer entry method is called, the customer ID field get changed with a new value, and also whenever we call the continue purchase method, the purchase amount, which is an instance variable, get changed. Therefore as many times we call these methods, the instance variables inside the object using which we are calling this method gets changed. So all in all, these methods are actually changing the state of an object by changing the values of the instance variables. Therefore customer entry and continue purchase, these two methods are impure methods. By definition, impure methods or functions are those which changes the state of an object. Now we will discuss about the access specifiers available in Java. There in total 4 access specifiers are available: public, protected, private, and default. The access specifiers are used to restrict the level of access of the members of a class. By saying members, I want to mean that both instance variable and methods. Now if public access specifier is used, then the level of access is not restricted at all. That means member variables or member functions, if they have public access specifier, they are accessible from anywhere. Protected and private access specifiers restrict the level of access of the members of a class up to the class where they are actually defined. That means if a method or a member variable have protected or public access specifier, they only can be accessed inside the class where they are defined. But the difference is that protected access specifier is, if protected access specifier is used, then that member can be inherited in class. But private access specifier, if it is used, then that member variable or method cannot be inherited into another class. That means protected access specifier is more to do with the inheritance property of Java. If you don't use any access specifier, then it becomes default access specifier. As the case maybe we have seen in our video lectures, that I have not used any access specifier with member variables or methods. Therefore, if we don't use any access specifier, that member function or variable or instance variable will have the default access specifier, and its access will be limited to the package only. We'll again come back to this point when we'll discuss the package. Now, apart from the access specifier, there are some non-access specifiers are also available in Java. These are static, final, and abstract. Now we'll discuss about them with example in next few slides. Here in this slide I have discussed about the static non-access specifier or static modifier with the help of an example. As you can see here, I have defined a static method and also a static instance variable. Now inside this main, I have called the counter function method using the class name and dot operator. This is the case for a static method. Whenever we want to access a static method outside the class where it is defined, we need to use or we can use the class name and dot operator. No need to create any object. Recall from my previous video lectures is that if we declare a member of a class as static, then there will be a common memory allocation for it for all the objects of that class. So to call or to use a static member of a class, we can use the class name and dot operator. We need not create any object of that class to use the static member. Apart from that, inside the class where a static member is defined, a static method can only access another static member of that class. That means as the counter function here is a static method, it can only use this count variable as it is also a static member of this test1 class. But if we try to use the variable p, which is a non-static member of the test1 class, then there will be a compile time error. You can try in your system or PC to use the variable p inside this counter function and compile it to see what exactly the error occurs, or any errors occur or not. That will be a good exercise to understand the static members of a class. So all in all, what we have learned from this slide is that a static method can only access another static member variable inside the same class. It cannot access a non-static member variable. Now outside the class where these static members are defined, as in the case here inside the test2 class, if we want to access a static member of any class, we can use the class name and dot operator. We need not create object of the test1 class. Now the final non-access specifier or the final modifier can be used to finalize a method. Now by saying finalize, I want to mean that if the class where a final method is defined is inherited by another class, as in the case here, test2 class inherits test class, then it cannot override the final method which is defined inside the base class. You can recall my previous video is that when inheritance occurs, the class which derived some property from another class is known as the derived class. Here test2 is a derived class, and from the class where the properties are derived is known as the base class. Here test is the base class. Therefore, if a method is defined as final, it cannot be derived once again inside the derived class. Here you can see inheritance can be done with the extends keyword. The whole line is that class test2 extends or inherits class test. So the takeout is that if a method is defined as final, then it cannot be override in a derived class. Where the derived class is created from the base class where the final method is defined. You can also test this program in your PC to understand in a better way. Now in this slide I have discussed the abstract modifier. An abstract modifier can be used to define abstract methods. As in the case here, the display method is declared as abstract, as you can see, but there are some interesting characteristics of abstract methods. If a method is declared abstract, it must not have the function body. As you can see here, the show data method, which is a non-abstract method, has the function body, but the display method, which is an abstract method, does not possess function body. This is the first point. The second point is that if a method inside any class is defined abstract, here the display method is defined as abstract inside the class test, then that class also must be defined as abstract. Okay, so as you can see here, if any method defined as abstract inside any class, inside a class, then that class has to be abstract. But the vice versa is not true. That means if a class is defined as abstract, then it is not required that all the methods defined inside that class is abstract. As in the case here, we have the abstract class test1, but one of its method is abstract and one of its method is not abstract. Now the third point is that if a derived class is created from an abstract class, as the case here, test2 is derived from test1, which is an abstract class, the test2 class must implement the abstract method. By saying implement, I want to mean that inside the derived class, the abstract method should have a function body. As you can see here, the display method, which is an abstract method inside the test1 class, and inside the test2 class, which is a derived class, the display method has a function body. This is mandatory. And if we don't want to implement the abstract method inside the derived class, that means if we don't want to write the function body inside test2 for display method, we have to declare the test2 class also as an abstract class. That makes the third point. If a regular class extends the abstract class, then it must have to implement the abstract method, or it must have to be declared abstract as well. That means if we don't implement the display method here, we have to make this test2 class as abstract class. So therefore, both abstract and final, these two non-access modifiers are more to do with the inheritance property of Java. Now we will discuss a few points about different type of calling methodology available in Java. There are actually two type of function calling techniques available in Java: call by value and call by reference. Now before discussing the points or the difference between these two function calling method, we will first understand these two techniques with an example. Here in this slide I have designed a class named employee. It is having 4 member variables or instance variables, a method named input which accepting 4 values and storing these values into respective fields, the display method which displaying the stored values, and the calculate salary method which is calculating the total salary and returning that value. Now inside another class which is having the name test, I have defined the main method and created an object of the employee class, and using that object I have called the different methods of this employee class. I want to emphasize here this line particularly, emp1.input, where the input method is called with the required values. What happens, we have already discussed. After program execution sequence encountered this line, program execution sequence jumps from this line to the definition of the input function, and the values of actual parameters get copied into the formal parameters. That means n will have the value Ram Sharma, en will have the value 932, y will have the value 2010, and bs will have the value 25,000. Inside the input method, this value get stored into the respective field. That is the body of the input method. Now in this type of function calling, if I change the value of n, that does not affect the actual parameters. Only thing what happens here is that the value of actual parameter gets copied into the formal parameter. This type of function calling is known as function call by value method. Here I have shown an example where function call by reference is used. Here, instead of simple variables or values, I have passed two objects of the class test1, as you can see here. Now before passing these two objects into the interchange method, I have assigned some values into the object. T1 has the value 10 and T2 has the value 20 before the interchange method is called. Now after the function calling is done, that means the body of the function get executed. If we see the value of the objects here in the output, I have displayed the values of the object. You can see the value of both the object changed. Now T1 is having the value 20, which is earlier 10, and T2 is having the value 10, which is earlier it was 20. So the function call has changed the value of the formal parameters, the actual parameters. This interchange function actually changed the value of the actual parameters. So how this happens? To understand it, that let's see this example. Whenever we create an object, required memory get reserved, as we know from my previous lectures. So therefore, whenever we created the T1 and T2 object of the test1 class, the required amount of memory get reserved. Here, this is the memory location for T1 and this is the memory location for T2. Now whenever we have passed these two objects into the interchange function, which is having two object reference of the same type of the same class to which T1 and T2 belongs, that is test1. After this function call occurs, both A and B starts pointing the same memory location as T1 and T2, as you can see in this picture. So whenever the interchange function call occurs, A starts pointing to the memory location where T1 is pointing, and B starts pointing to the memory location where T2 is pointing. As A and B pointing to the same memory location for T1 and T2 respectively, any change made by A and B will affect T1 and T2. This is what happened. So after this function call, anything we do with A and B will affect T1 and T2. So all in all, the function call by reference technique is an interesting one, where any changes made in the formal parameter here will affect the actual parameter. Also, in function call by reference, instead of passing simple values or variables, we are passing objects. Now, having grasped the concept of function call by value and call by reference, we will again go back to the slide where the difference between these two techniques have been discussed. Now I think it is easily understandable. The actual parameter copies into the formal parameter in case of call by value, as we have seen. But in call by reference, actual parameter is referred by the formal parameter. The actual parameter T1 and T2 is referred by the formal parameters. Any changes made to the formal parameter does not affect the actual parameter, as you have seen in the call by value, but in case of call by reference, changes made to the formal parameter affects the actual parameter. In call by value, parameters are of primitive data type, we have seen this, but in call by reference, objects are used. The fourth point is very important and interesting one. In call by value, only one value can be returned, but in call by reference, more than one value can be returned. How we can achieve this? To understand it, we will again go back to the call by reference technique. As you can see here, if test1 class have more than one instance variable, say it will have 2 or 3 instance variable, and if we assign values to those instance variables here using A or B, that will reflect here in T1 and T2. That means any number of instance variable we change here using A and B will affect T1 and T2. Therefore, we can return more than one value in call by reference technique. Okay. In this slide, I have discussed an important application of method, that is function overloading. Function overloading is a process where we define more than one method inside a class In this slide, I have discussed an important application of methods or function in Java, that is function overloading. Function overloading is a process by which a same function or a single function is defined more than once inside a class, as in the case here for the add function. Here I have defined the add function three times, and for all the three definitions, the function signature, that means the return type, the arguments are different. As in the first case it is int, in the second case function parameters and return type are double, and in the third case it is string. Now inside this main method, whenever we are calling the add method with two integers, the function definition with two integers get executed. Therefore, if we call the add function with two doubles, then the function definition with two doubles get executed, and the same case happens with the string data. Therefore, Java decides which function definitions will execute it as per the data we are passing it at the time of function call. This is the essence of function overloading. Here the same function with the same name is defined more than once, and it is executing, or the appropriate definition of the function get executed as per the data we are passing at the time of function call. You can practice this example in your PC, or you can dry run in your textbook if the PC is not available, to understand the concept in a more better and clearer way. Now, why we need function overloading? Through function overloading, Java implements an important concept, say polymorphism. Also, the function overloading makes the programming language, that is Java, extensible. By saying extensible, I want to mean that using function overloading, we can extend the functionality of a method. Again, we will go back to the function overloading example. Using function overloading, we make the add function work for integers, for double, and for string. If the function overloading property is not available, then we have to write three different functions for the three different needs. Hence, using function overloading, we are able to extend the functionality of a single function. Hence, function overloading makes programming language extensible. The last topic of this video lecture, this keyword. This keyword refers to the current object inside a method. By saying current object, I want to mean the object using which the method is called. You can see in this example the input method of the test class consists of two formal parameters, and eventually the name of these formal parameters coincide with the instance variable. X and Y, the formal parameters, also X and Y is the instance variable of the class test. Now when you call the input method, X and Y will have the value, as in the case here 40 and 70 respectively. Now if we want to assign these two values into the instance variable, how we can write? If we write x equal to x, that will create a confusion. So to distinguish between instance variable and the formal parameters, I have to clearly segregate between instance variable and formal parameter. To do this, I have used the this keyword. This keyword refers to the object using which the method is called. So here T1 object is used to call the input method. Therefore this dot x means T1 dot x, which is the instance variable. This dot y means T1 dot y, which is another instance variable. Therefore we clearly segregate between the instance variable and the formal parameters. So this is all about the this keyword. So in this video lecture we have discussed different type of functions available in Java. Go through this video again and again to understand this important concept, as methods or functions a very important part of Java program. Go through the exercises of your book, go through the homework given here. These are very related to the topic which I have discussed in this video lecture. If you have any query, please put those query in the remark section or the comment section of the video. And thank you.